Hey everyone, I'm Dr. Surjit Singh, and today I want to take you back to the year 1967 when my journey with computers began. One evening in the fall of 1967, I saw two punched cards lying near a dustbin in my hostel at Punjab University, Chandigarh, in India. I picked them up and wondered what they were and about their use. I came to know from a friend that an IBM 1620 computer had been gifted to our university by USA. I learned that the experts from US would be talking about Fortran programming at our campus for 10 days. I managed to bunk my chemistry classes for 2 hours every day and attended the free classes. About 15 more people, all unknown to me, were also present there. And on the very first day, I decided to pursue this subject at least as a hobby. Little did I know that computer programming would become the profession that I would pursue for the rest of my life. The IBM 1620 that we had in 1967 had a 20 KB RAM. So point cards were the only secondary memory available for input and for intermediate output. The CPU was located at the other side of the room that did not have a monitor but a series of blinking bulbs, as we can see. Card punching machines worked offline, which means they were not connected to a computer. At a time, they could hold 250 cards. One card at a time would automatically go into the punching area if the auto feed of the machine was set to on. Cards were placed in the punching zone and a QWERTY keyboard was used to punch holes in the columns of the cards. The card feed key was used to release cards. Good quality machines would also print characters in the top margin while punching holes in the cards. When the cards were punched, rectangular chippers coming out of the holes would fall into the bucket placed below, which had to be emptied regularly. I used to give those equal sized chippers to fine art students. My sister, who did BSc in home science, made excellent pieces of art using these leftovers. Before putting the cards in the card reader, we would align the cards by tapping them on the edges. A slanted cut at the top left corner ensured that all cards were kept upright with the front side facing us. The deck of cards was fed into the card reader. It had 960 brushes of electric wires to sense the presence of holes in each card. It could read 250 cards in 1 minute. About 1 in 1000 cards would get rejected by the reader and the process would stop. Such a card was fed again. Some soiled cards would sometimes jam the reader. The reader had to be opened to remove the torn card. A duplicate card was punched on the spot before proceeding further. After successfully reading the deck, the information was stored in the RAM of the computer. The card reader unit also had a card puncher to get the intermediate output in the machine language. That is, we would input the source program written in Fortran to the card reader and get the exe version from the card puncher. The user's machine language program would then be loaded in the card reader and it would in turn read the user's deck of cards. These series of steps comprised of executing a program. A silly mistake in the program such as 0 instead of O or 1 instead of I would mean having to discard the entire pack of exe cards. The final output was printed on the line printer located in the other corner of the room. We could print numerals, capital alphabets, and a few arithmetic symbols on this line printer. Every user was allocated half an hour during which he had to run around the room but was still quicker than how fast the computer could process the input and print the output. Often, the output would be a one-line error message, and I would have to run for the deck of cards to re-punch the erroneous card. This card puncher was also attached to the computer to get intermediate results. if they were required by the subsequent program. This was very common for long programs that were beyond the size of the RAM of the computer. With RAM size limited to 20 KB, space optimizations and fighting for each byte of memory was a necessity and not just a requirement for cracking FANG interviews. The standard punched cards had a mesh of dots consisting of 12 rows and 80 columns. The columns were numbered 1 to 80 and the rows were numbered 12, 11, 0, 1, 2, 3 through 9. A rectangular hole could be punched at any one of these 960 locations. Each column represented a character, hence a card could store a line of 80 characters. A blank column represented space and had no hole in it. For writing a digit in the column, a single hole was required in that column. From top to bottom, a single hole represented plus, minus, 0, 1, 2, up to 9. That is, a single hole in the 12th row represented plus, 11th row represented minus, 0th row represented 0, and the last row represented the digit 9. Only capital alphabets were allowed. Two holes in the same column were used to represent alphabets. 12 one pair of holes represented A, 12 two pairs represented B, and 12 nine pair represented I. The pairs 11 1 through 11 9 represented the characters J through R, while the remaining 8 characters, namely S through Z, were represented by the holes pairs 02 through 09. Special characters such as star, slash, exclamation at, dollar, etc. and the parentheses were represented by 3 holes in one column. Typical combinations were 1238 and 1148 for such characters. In those days, I remembered all these combinations and was able to read the writing on cards just by looking at the holes. A deck of 1000 cards had a thickness of about 12 inches. The deck was held together using a soft rubber band. If the deck wasn't opened for months, the rubber band would soften and often stick on the top and bottom cards. So these two cards had to be replaced to prevent their jamming in the card reader. Only 72 out of 80 columns were used to write Fortran programs, and the last 8 columns were used to number the cards. In case the cards accidentally went out of order, this card sorter was used to sort them back in order. The sorter had 10 buckets for collecting them. The sorting machine would read one specified column of the card and then separate them into 10 buckets. 2 passes were needed for 2 column data. This became the basis for the bucket sort algorithm. Alphabetic sorting was more complicated and it required 2 passes for every column of the card deck. 1967 was a very special time in my life and laid the foundation of my programming ethic to think in terms of space and time optimizations. I can relate a lot to the lead code problems where we discuss clever solutions to save time and space. Thanks for your time and for watching the video.